start recording. And again, I just want to update you. Sometime tomorrow, I will post one more assignment on 6.1, and hopefully on 6.2, that should be your last assignment before the finals. Finals, I will give you like 1 week time. Sometime in, like, I should say what week I need to post it, because I need to post the grades by December 15th or 16th. That's what I'm hoping to. So not the next week, but the week after, I'll post the finals and I'll give you 1 week time. Is that making sense to you all guys? Okay, that's great. Because I want to give you enough time. I know you're all teaching. You might be busy with your own classes and all. So that is the reason I'd like to give you as much time as I can for your finals. But not more than 1 week, certainly, that I feel it's too much time. So I think 1 week, I think pretty much you can manage. So let us discuss about this. And again, I just want to tell you guys, I'm not going to completely solve these questions for you, because this is going to be an exam. And certainly I felt, I don't know about you guys, this exam was a little bit easier than the first one. Am I correct in saying it, or you don't agree with that? Okay, but let's start asking questions. And any questions, guys? Anything you want to talk about? You all can hear me, right, folks?
Yes.
Okay, any questions? I'm going to share a PowerPoint. I just want you just tell me whether you can see this PowerPoint or not. This is an empty one. You all can see this, right? Again, if you type it on the chat session, I cannot hear you guys. I cannot see that because this is occupying the entire window.
I can see it.
That is great.
I can too.
Okay, that is awesome. Come on, fire away. Any questions, guys? I know Valerie is the one who asked. Is she there? I just want to make sure.
I just got
Okay.
in.
Okay. Because you said you have some questions on 4.1, some of the topics you want me to go over, right?
Yeah.
Is that right?
Yes.
Yes.
Yeah, I'm trying to read
Okay.
and make sense of all the letters in that section.
Okay.
There. Let me look it over here just a second here.
Sure, take your time. In the meanwhile, I want to ask the rest of the guys, other than 4.1, you have any questions, guys? Again, you need to speak here at this point, because chat, if you're typing something, unfortunately, I cannot see that. Let me log in into my other computer. Maybe I can see the chat session on that.
I mainly just want to, this is Pam.
Hi, Ben.
I just want to listen to the discussion on 4.1 so that I make sure I'm understanding things correctly.
Okay. Sure. And just to want to give you heads up on 4.1, and other than 4.1, anybody has any questions, guys? I just want to make sure I'll touch base with that before I go to 4.1.
Well, I'm not sure my proofs are as solid as I'd like them to be, but I tried not to go by example and tried to think more about statements. So,
Which proof you are talking about?
I think 6.
I am going to give you a hint. I think hope everybody can hear. That is a big hint for both 6 and 7. Everybody can hear me, right?
Yes.
Those both results are wrong. So don't try to prove it. Come up with a graph in which it is going to be wrong.
Okay.
Yeah.
So both of them, both 6 and 7, you need to come up with a graph. Frankly, this is a big hint in a sense. Like, come up with a graph. For example, 6, that graph should be simple and it should have an Eulerian closed chain, but the total number of edges should be odd. There are so many graphs in the textbook which works. Otherwise, you
Right.
can cook your own graphs really, even for this
Right.
7. So once you sketch the graph, and that graph is good enough, that is a good enough proof. So so coming up with your own graph, that's all really I'm looking for there in 6 and 7. So the
Okay.
only
So
proof
basically,
yes ma'am,
you're saying that if we come up with a counterexample, that's our proof.
that's your proof exactly for both 6 and 7.
Okay, great, great. Okay.
So the only proofs, if at all, in this are 1 and 2.
Okay.
Yeah. So let us talk about 4.1. I'll talk a little bit about 4.1, and then I'll try to discuss some of the topics which I think I have asked in this exam. Yeah. Only always ask me. No. See, we are talking about relations here. Let me put a pen and then. Mainly, we are going to talk about binary relation. Binary relation means you're comparing two things. That's all you are doing. That is the meaning of binary. You are comparing two things. And please remember, throughout this topic, you will have a set X, and we'll assume that is a finite set. Or sometimes even infinite works, but most probably finite works most of the times. But sometimes you can take infinite as well. And it is a set of certain elements. For example, your set can be as simple as this. Or your set can be all the males in United States. So any of these are finitely many numbers, right? Even all the males, that is a huge number, but it's certainly a finite thing. Now you want to define a relation. Again, there is no rule or anything when it comes to the relation. So all you are doing is you're taking, you know what is x cross x, right? For example, if x is 1, 2, and 3, we define the Cartesian coordinate of x cross x as, you will write all ordered pairs a comma b, where a belongs to x and b belongs to x. That means for this example, when x is 1, 2, 3, your x cross x will be 1, 1, 1, 2, 1, 3, all possible. Take, close your eyes and pick any two kind of thing. And similarly, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, and 3, 3. Since x has 3 members, x cross x has 3 times 3, 9 members. So that's what you need to recognize. So if x has n members in it, then Cartesian coordinate will have n times n square members in it. So the definition of the relation is simply nothing but take some of them, a subset of x cross x. That is the meaning of the relation. For example, when x is 1, 2, and 3, your relation might be just close your eyes and pick some from this. Maybe I pick this. Sorry. 1, 1, say 1, 2, 3, 1, and say 2, 3. Pick any. This is one relation, or this might be another relation. Maybe I'll call this as R1 and I'll call this as R2. Maybe in this I'll put 1, 1, 1, 2, 2, 2, and say 3, 2. So these are all different relations on X. So you will say X R1 is one binary relation. X R2 is another binary relation. So you can define as many relations as you want. And these relations are reflexive or symmetric or anti-symmetric. There are a bunch of other definitions which are coming into picture. For example, I might define, if you want a more practical or realistic example, I can give something like this. So in this particular example, if you take R1, in this R1, 1 is related to 1, 1 is related to 2, 3 is related to 1, 2 is related to 3. But in R1, if I ask, is 2 is related to 2 in R1, the answer is no. Because there is no 2 comma 2 in R1. But 2 is related to 2 with respect to R2, because I saw 2 comma 2 in R2, but I don't see 2 comma 2 in R1. So when I say whether two elements are related, you just go back into that relation and see whether that ordered pair is present or not. It is as simple as that. So for example, I'll give you one more. Insert a new slide, a blank one. For example, my X might be all the people in Math 540, our class. There are 12 people in this class, so there are 12. So it has 12 students. So my X in this case is Valerie, Nisa, and Andrew. Maybe there are lots of people. I remember all of your names, but I don't want to write it at this point. Now I will say, I'm going to define a relation like this. Take any two people, one I call A and the other call B. A is related to B if and only if A is a friend of B. So that means, for example, if Valerie and Nisa were friends to each other, then I will say this is a relation called as R. B is related to N according to this. For example, Valerie and Andrew were not friends of each other, then B is not related to A for Andrew and B for Valerie. That is the way you'll denote. So this is relation. There is no rule or something like this. So relation can be something like this. Or my X can be, I say, all real numbers. Now in this case, X is an infinite set because it has all the possible numbers in the world. Now this is another example and this is another example. Now I am saying close your eyes and pick any two numbers. They are related if and only if, say, A is less than or equal to B. So if you take this relation, then I ask, is 1 is related to 2, then all you will go back and check is 1 is less than or equal to 2. Is it yes or no?
Yeah.
So the answer is yes. Now 2 is related to 4, and the answer is again yes. But if I ask, is 5 is related to 2, that means is 5 comma 2 is a member of the relation. What you will say is 5 is less than or equal to 2? No.
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 No. So the answer is no. It is as simple as that. So the relation is something you can cook up as any relation you want. And the relation, there are certain other properties if the relation satisfies, you will call that relation as reflexive or symmetric or transitive or anything like that. So for example, I'll explain it. A relation is said to be reflexive, means there is a definition in the book, so I'm not going to go the formal definition. A is related to itself for all A belongs to X. That means if you go back into this, I'm going to go to the previous page. This page. R1 is not reflexive because 1 is related to 1, but there is no 2, 2, and there is no 3, 3. So this R1 is not reflexive. Do you think R2 is reflexive, guys?
No,
No.
because 3 is not there.
Yeah, 3, 3 is missing.
Right.
Now if I come back here, X is all the people in math 540, and 2 people are related if A is a friend of B. Do you think this relation is reflexive?
Am I a friend to myself?
Yeah, that's what I'm asking.
Well, hopefully we are.
Or at least be nice to ourselves.
Very bad decisions. You should be a friend of yourself, right? So this is reflexive. And this is more philosophical, but yes, it is. Now, what about this? Do you think this is reflexive?
No, because they're numbers. Oh yeah, because they're equal to each other.
They are equal to each other. So the equality symbol, it is reflexive. 1 is less than or equal to 1. Of course it is.
Yeah.
If I remove
Yeah.
the equality symbol there, that is not reflexive anymore. Okay, guys?
Gotcha. Okay. Yep.
Now the next one is, if it is not reflexive, again, really the 3 most important ones were reflexive, symmetric, and transitive. And the
Right.
rest of them are really, really not that important by any standard. But since your textbook talked about, I'm going to talk about this. So I'm going to talk about these 2 later. Then what is the meaning of a relation is not reflexive?
Well, R1 is not reflexive.
R1 is not reflexive. And R2 is not reflexive. It is as simple, if it is not reflexive, it is not reflexive. And the other extreme is, I want to make sure I use the same notation as irreflexive. I think that is the word they used, if I'm not right. What is the meaning of irreflexive?
Yeah, that's where I'm confused.
Yeah.
Irreflexive means A is not related to itself for all A belongs to X. That means
So-
if you go back, yes, ma'am, tell me.
So if you had a R3 that was 1, 2, 2, 3, and 3, 1, and that's all it contained, that would be irreflexive because there is nothing in there reflexive.
Exactly. Because if you take R1, it has 1, 1. So though this is
Okay.
not, it is not reflexive because it doesn't have 2, 2 or 3, 3. But I cannot call it is irreflexive because 1, 1 is there.
Okay.
So she is absolutely right. So I'm going to define a new relation. I say my 1, 2, say 2, 3, and say 1, 3. This is irreflexive. That means this is the other extreme. That means there is no 1, 1, no 2, 2, no 3, 3, nothing. So reflexive is one extreme, irreflexive is the other extreme, not reflexive is somewhere in the middle. Sometimes it might be, for some of them it is reflexive, for some it is not.
Okay.
Am I making any sense?
Yeah, that
Yeah.
makes more sense. The book didn't really clarify too much there.
Yeah.
You know,
For example, even if you take this is reflexive. I'm assuming everybody is a friend of yours.
themselves, unless sometimes people take stupid decisions for that particular moment. Maybe they are not their own friend. That is irreflex.
Okay.
Yeah, I have seen people getting drunk and driving. At that moment, I'm assuming they are not their friends. So those are the reflexive, but the most important thing is reflexive. Now the symmetric. The symmetric means if A is related to B, then B is related to A. That means if AB is one member, then BA should be a member as well. It is as simple as that. For example, if you go back here, again, I'm keep going back to the previous definitions. R1, if you see 1, 2, then there should be 2, 1 also in there. So R1 is not symmetric. Am I making any sense, guys?
Mhm.
Yeah.
For example, in this case, 1, 2 is there, then 2, 1 should be there for each and everything. If 2, 2 is there, 2, 2 is there. So this will, I can make this symmetric by like this. For example, R2, I can, maybe I'm going to write it here. Maybe let me use a new slide. If you
So
observe,
I'm
Yes,
just
ma'am.
curious. Can a relation be symmetric and reflexive?
oh yeah.
Okay.
For example, there are some relations which are both reflexive, symmetric, and transitive. You will call them equivalent relations. You need to come up with some examples as well for that. That is one of the problems.
Okay.
Right, that was.
Okay.
Can you
If you
have a
take-
4
Okay.
in R1 when you don't have it in X?
Which, oh yeah, I am so sorry. That is wrong. Oh yeah, that is not even in X. Why the hell I put 4 there?
Okay,
For example, if you take R1, see 1, 1 is there, its opposite should be there. 1, 2 is there, its opposite is there. 1, 3 is there, 3, 1 is there. So this is symmetric. R1 is symmetric. You really don't care about the pairs which are not in there. For example, 2, 3 is not in there, so I don't care about it. For example, I can add this. If I add 2, 3, then I'm supposed to add the other way as well. Otherwise, it is not going to be symmetric.
Okay.
So R1 is symmetric, but that is not reflexive. You can see that because 2, 2 and 3, 3 are not there.
Right.
But if you take R2, that is both symmetric as well and reflexive, both, because 1, 1, 2, 2, 3, 3 are there, so that is reflexive. And whenever 1, 2 is there, 2, 1 is there. 3, 3 is there, the other one is also there. That is same as itself. So this one is only symmetric but not reflexive. This one is symmetric and reflexive. So when I ask these examples, you can cook up on your own, really.
right.
Okay.
So just take and just put some ordered pairs, and as long as you get what you want, you're done. For example, if you take this one, all the people, do you think this relation is symmetric? A is related to B if A is a friend of B. All the people in Math 140.
Well, no offense. I don't know. Well, if a
When
friend,
I-
I would hope.
Yeah,
I think when I use the word friend, I think it should go both ways, right?
Right. Well, I'm hoping so. Yeah.
Otherwise, I think you'll call stalking, I guess. You don't call that as a friendship. So A is a friend of B. That means I'm assuming B should be a friend of A as well, because I use the word friend there. So that itself implies something. But if I define these relations, for example, X is say all males in the United States. Okay. And if take any two males, A is related to B, if and only if A is a brother of B. Do you think this relation is symmetric?
No, because you're not a brother to yourself.
No, I'm not talking about reflexive. Symmetric.
It's
Oh.
symmetric, not reflective.
Well, then
If
I would
A
say
is-
symmetric.
Yeah, that would be, because it's only all males, right?
Yes.
Okay.
If A is a brother of B, then of course B should be a brother of A, right? I'm not talking about elder brother or younger brother. I'm not putting any restriction. I'm just saying a brother.
Okay.
And
Then
now I
yes,
think
I
she
think-
got it. It is symmetric.
Yeah.
She got a nice point. If I remove the word males and I say all people, then do you think this is symmetric?
No.
Can you tell me why not?
Well, if A is a brother of B, B could be a girl. So
That's awesome. That is awesome.
B
That's all I
could
want
not
to
be
say.
a brother of A. Yeah?
Exactly. You are absolutely correct.
Okay.
So the symmetric completely sometimes depends on the set, sometimes depends on the relation, sometimes most of the times it depends on both. So you have to be very careful. So that is the meaning of symmetric.
Okay.
Okay. Now I'm going to add one more slide here. Now, before they go to transitive, there are some other extremes here. That is going to be asymmetric. This is a little bit confusing for the people. Non-symmetric is comparatively not so bad. The definition simply will tell you what then that is not symmetric. It is as simple as that. Non-symmetric, it is as simple as that. So the definition is simply not symmetric. For example, if you say this one is symmetric and the R2 in this case is, oh, that is also symmetric. I apologize. I need to pick. For example, this one, all people, then this is not symmetric. It is as simple as that.
Okay.
Now, what is the meaning of asymmetric?
Can you
There are
do
two-
one like the
Yes.
graph dots, like vertices and arrows to indicate asymmetric?
Okay. Yeah, I'm going to explain like that as well, but I will explain the regular way and then I'll draw the graph also.
Okay.
Okay.
Asymmetric means whenever A is related to B, that means B should not be related to A. If I want to give an example, I can cook some things on my own really. Okay, let us make this. Let us say all real numbers. Now I am going to define a relation like this. If and only if A is strictly less than B. I'm not putting equality symbol here. Now, if you take any numbers really, if I say one is related to 2 according to this relation, guys, is it yes or no?
Yes.
That's a yes.
Because 1 is less than 2, so the answer is yes. That means 2 should not be related to 1.
Correct.
Is it right? Because 2
That's
is
correct.
1 is less than 2, 2 has to be greater than 1, right?
Correct.
So this is S. So this relation is asymmetric. If I put an equality symbol there, then that is not going to be asymmetric.
Oh,
Okay. Or I can cook some things on my own. Let us write something on my own, really. So that is advantage with this. If you sometimes if you can't think these realistic examples, just write something on your own. Do you think this is asymmetric?
Well, I don't know how 4 can be in there because it's not in X.
Oh boy, I did that again. Oh man. Yeah. What do you think? Do you think this is asymmetric?
Yes, because 1, no, because of the 1, 1.
Exactly. The 1, 1, anything which is reflexive is not going to be asymmetric. Okay, because what is asymmetric says if 1, 1 is there, its opposite should not be there. But 1, 1 is opposite is 1, 1 itself. So this is not asymmetric.
So if you had like 1, 2, 1, 3, and 2, 3, that would be asymmetric.
Oh yeah, of course. Maybe 1, 2, and say 1, 3. Even I can stop right here, but maybe we'll put 2, 3. This is asymmetric.
So essentially, if I have AB,
Mhm.
BA can't be?
BA can't be there.
Okay, all right. Okay,
Mhm.
now I'm good.
Yeah. So if you want to think as a graphs, I think someone asked. For example, if I take this relation 1, 2, and 3, if I want to sketch the graph for R1, there are 1, 2, and 3. One is the digraph here. 1 is related to 1, so that is a loop, and 1 is related to 2, so the graph is going like this, and 1 is related to 3. So if there is a arc from 1 to 2, there should not be any arc from 2 to 1. So really, if you want to come up with your own relation, sketch any graph really. Make sure the arcs are going in one direction, then that graph will determine a symmetric relation for you. So this is going to give you an asymmetric relation on 1, 2, 3, and 4. Because 1, 2 is there, but 2, 1 is not there. And 1, 2, 3 is there, but 3, 2 is not there. So sketch any graph really. Just sketch a digraph. Make sure arcs are not going in both directions. There are no loops. Then you get your asymmetric thing.
Okay.
That is it is asymmetric. So you know what is symmetric, you know what is non-symmetric, you know what is asymmetric, and the other extreme is anti-symmetric. That is the other extreme. And anti-symmetric only tells you this. This is the other extreme. X is any set. If A is related to B, and you also know B is related to A, the only way that can happen is A should be equal to B. The only way both relations should happen is there should be a loop. Say for example, now the same example I am talking about 1, 2, and 1, 3. Now you know this is not asymmetric, right? You know that. That's what you guys told me just now because of 1, 1, right guys?
Right.
Do you think this is
Okay.
anti-symmetric? Do you think
What
this is
has
an anti?
anti-symmetric piece? but I don't know if you could call the whole thing
Whole
anti-symmetric.
thing is anti-symmetric. Oh, anti-symmetric definition is simply tells you this: if A is related to B and B is related to there, if both are there, then A is equals to B. If both are not there, then I don't care about it. For example, 1 2 is there. If 2 1 is not there, then I'm good. If 1 3 is there, 3 1 is not there, I'm good. The only times both are there when they should be equal to each other. So this is an anti-symmetric.
Oh, okay.
Oh.
If they were not there, I don't care about it. For example, if you take x is all real numbers. Now I am saying this. Take any two numbers. They are related if and only if A is less than or equal to B. Now if I ask, take any two numbers really. You know A is less than or equal to B. That means AB is there. And suppose BA is also there. That means B is also less than or equal to A. The only way A is less than or equal to B and B is less than or equal to A can happen at the same time when A is equals to B.
Right.
So this relation of less than or equal to is anti-symmetric. And please remember, this is a little bit confusing the way they word it. This is symmetric as well. No, you cannot say that. I'm sorry. I take my words back.
Okay.
I take my words back. Sorry, this is just anti-symmetric. Is that making sense, guys?
Yeah.
Mm-hmm.
Okay. For example, if you take this example, all the people, and if you know A is a friend of B and B is also a friend of A, then I cannot say that A and B are same. I cannot say that unless there is only one person in the entire class or he has a very sad life. He or she.
Gotcha.
So yeah, so this is anti-symmetric. So reflexive, not reflexive, irreflexive, or the extreme going from one positive end to the other end. Similarly, symmetric, non-symmetric, asymmetric, anti-symmetric, these are the steps in symmetry to think. But this is the only textbook I have really seen asymmetric and non-symmetric both. Most of the places I have seen, they only talk about symmetric and anti-symmetric. They don't care about the rest. Now, let us go to transitive. What is the meaning of transitive? That means if A is related to B and B is related to C, if I can conclude A is related to C, then that is transitive. For example, if I take X is all real numbers. Take any two numbers, A is related to B if and only if A is less than or equal to B. Do you think this is transitive?
Yes.
Yes, right?
Yeah, I
If you
think
know,
so.
yes, exactly. If you know A is less than or equal to B, if you know B is less than or equal to C, then of course I can say A is less than or equal to C. So this is transitive. For example, if I take this, all the people in this class,
But that's transitive, but it's not necessarily symmetric, and it's not. It could be
it is
reflexive.
So don't, I think this is one of the problems in the exam where you have to come up with an example. So don't tell the answers outside.
Oh, sorry.
No, I'm just saying that's fine. I know you can cook up your own examples. That is the advantage of this. If and only if A and B are friends to E, or A is a friend of B, I should say. A is a friend of B. You know this relation is reflexive. You know this relation is symmetric. Do you think this relation is transitive? Do you think this relation is transitive?
Not necessarily.
No, that's what I was gonna say. B can be friends with A and C, but it doesn't guarantee that A and C are friends.
Exactly. So this is not transitive.
Okay.
The advantage with this is, as I mentioned, you can cook up your own examples. No, I don't want this. I want the blank slide. Oh man. Okay, why not? This is fine. So you can cook up your own example, say 1, 2, and 3. Again, I'm just writing whatever comes to my head in this case.
You put a 4 in there again.
Oh boy, yeah. What is wrong with me today? I'm just on a different plane today. Okay, I have given something. I just wrote whatever comes to my mind. Man, my 3 is gone. Now I'm asking, do you think this relation is reflexive? Yes or no?
No, because 3, 3 is not there.
No.
Okay. Because 3, 3 is not there, not belongs to, or you can say 3 is not related to 3. Do you think this relation is symmetric?
No, because 3, 1 is not there.
Because 1, 3 is there, 1 is related to 3, but 3 is not related to 1. So this is not symmetric.
Right.
Do you think this is transitive? I don't know why I wrote 2 twice.
No, I don't think it is, because if
Why?
1 to 3 and 2 to 3, that means 1 to 2.
Because of this. Because 1, 3 is there, 3, 2 is there, that means 1, 2 should be there. So this
Right,
is not
and it's not.
transitive as well.
Yeah. Okay.
Suppose I added 1, 2. Now, do you think this is transitive?
Oh.
Needs to be 2 to 1, right?
What, sir?
Needs to be 2 back to 1, doesn't it? Or does it need to be 1 to 2? It doesn't matter.
I'm sorry, your voice is a little bit cutting. Can you speak again, if you don't mind?
It has to be 1 to 2 and not 2 to 1, correct?
Okay.
I think it's
It is transitive, right?
yeah.
But it will
Because
not
1,
be
1 is there.
2 to 1.
Which, why you need 2, 2? Okay, 2, 2, 2 is there.
Right. My question was, it would not be transitive if it was 2 to 1, right? It has to be 1 2.
It has to be 1, 2, yeah. Because see, 1 is related to 1 and 1 is related to 2. So 1, 2 should be there. Okay. And 2 is related to 2 and say 2 is related to 3. So 1, 2, 3 should be there. That is there. And 1, 1 and 1, 3 is there. So 1, 3 should be there. So this is transitive, right? Is everybody okay with that?
Yeah.
Can you go through that once again?
It's almost like you need to check. You see that 1, 1 is there, right? Is 1 comma some
Right.
other thing? Okay, 1, 3 is there. So 1 goes to 1 and 1 goes to 3. So 1 should go to 3 and that is already there. For example, 2 goes to 2, and where are other places 2 is going? And 2 is going to 3. So 2, 3 should be there. That is also there.
Okay.
And say 1 is going to 3, 3 is going to 2. So 1, 2 should be there. That is we added.
Okay. Okay.
So all of them are there. If at least the first, you don't really care about the pairs which are not even there in R. You only
Okay, I have a
worry about.
question.
Yes, sir. Yes, ma'am.
You have 3, 2, and 2, 3. Should that not include then 3, 3 to be transitive?
Oh, yeah, you were right, man. You got a nice point. You see that? That's what happens when you cook things on the fly. She is right. 3, 2 is there, 2, 3 is there, so 3, 3 should be there. So, whoops.
By that logic, shouldn't 2, 1 be there also?
Why you need 2, 1? Because 2, if you want to have 2, 1, is 2 is going to 1 anywhere? So the first step itself is not doing. If, for example, if I go to 2 to 3 and you have 3 to 1, then 2, 1 should be there. But 2, 3 is there, but there is no 3, 1. So 2, 1 need not be there. I don't think 2, 1 is stopping us. 3, 3 is the one which is screwing up. So you observe if you are, it's almost like I'm giving a hint for one of the examples. If I put 3, 3 here, then this becomes reflexive and transitive. But I don't think this is symmetric.
Okay. Okay.
Because if I suppose add 3, 3, then that becomes 1, 1, 2, 2, 3, 3, that is reflexive. I think this is transitive. But it is not symmetric because 1, 3 is there, but there is no 3, 1. So these things you can sort of come up with these examples on your own. That's what I'm trying to emphasize.
Okay.
For example, if I simply write this, so if you look into the graph wise, these are 3 sort of independent loops. So if you think of graphically for the transitivity, if there is an arc from A to B and if there is an arc from B to C, then there should be an arc from A to C. That is what the transitivity talks about.
Okay.
If there is no arc from A to B, then you don't worry about it. So you can take the relation and sketch the corresponding graph and see whether this is happening or not.
Okay, can I give you an
Gotcha.
example? Okay, if you have 2, 3, 3, 2, and then 1, 2, and 2, 1, and then 2, 2, and 1, 1.
Okay.
I see that is not reflexive because 3, 3 is not there, right?
Yes,
Okay.
it's not reflexive. This is symmetric, right?
Yeah.
But it's
And
not
this-
transitive
Why not?
3,
because 3, 3 is not there.
Why
The
you
one
need
that
3?
she just gave.
Yeah, this is the example she is giving.
and 1, 3 is not there.
Why you need 1, 3?
Because you have 1, 2, and 2, 3.
No, oh yeah, you are right. 1, 2, and 2, 3. So 1, 3 is not there. You are right.
So
And
to
if
get
it's
it
3, 2, 2, 3, you would need 3, 3.
right, so then it becomes reflexive.
No. Why you need 3, 3 here? You need 2, 3 and 3, 2. So you need 2, 2. 2, 2 is already there.
What if you put those in
But
up the
what if,
other?
Oh
what if we
yeah.
have 3, 2?
Oh yeah.
Yeah? Okay.
Man, you guys are catching. That's awesome. You guys are doing great. Yep. You are right. This is not transitive too.
Okay, so you would need 3, 3 in there, correct?
You need 3, 3 in there. You're absolutely right. And also, as he mentioned, you need 1, 3 in there as well. Because 1 to 2 and 2 to 3. So you need 1, 3. And also you need 3, 3.
And you would need 3, 1 also, wouldn't you? For 3, 2, 2, 1?
Oh yeah, it is missing bunch of things.
Okay.
Yeah.
So you really have to check all possibilities, right?
All possibilities. So my strong, that is the reason I'll always go with my life being simple. For example, if I take this, x is 1, 2, 3 or 1, 1, 2, 2, 3, 3. Do you think this is reflexive?
The
Yes.
graph?
No, this one. The R. Don't worry about the graph.
Okay.
1,
R
1,
is-
2, 2, 3, 3 is reflexive, yes.
What about, is it symmetric?
Yes.
Yes.
Is it transitive?
No.
Why not?
You go from 1 to 1, you have to go back to 1. So 1 to 1.
Oh, yeah,
Right.
yes it is.
So yeah,
Yeah, it is.
2 to 2, and
It
then
is.
you
Yeah,
go
it is.
2 to 2, 3 to 2. See, and that's where I'm having a hard time because I can't separate out picking like separating
I know
things.
that is the reason sometimes the realistic example, sort of like friends or like all the people and two people are related if they belong to the same family. You see that you can come up on your own. So if A and B are part of a family and B and C are part of the same family, then A and C better be in the same family.
Okay, so this is just like I do with my kids in transitive in geometry. There has to be that connector in there, and the only connector for 1, 1 would be itself. The
Exactly.
only one for 2, 2 would be itself, and the only one for 3, 3 would be itself. So yes,
Exactly.
technically it is transitive.
Yes, it is transitive. So the relations like this, when that is both reflexive, symmetric, and transitive, these relations are extremely important. These relations are called equivalence relations. That means it has all the good properties in it. That's what it means. See, cooking up equivalence relationships is extremely simple. You just put these things and that is good enough. Or I might simply say my R is simply 1, 1. Yes, that is reflexive, symmetric, and transitive.
Yeah, okay.
Right? So if I take my R as an empty set, for example, that means I just don't put anything. Do you think this is reflexive, symmetric, and transitive? I don't think this is reflexive, right? The definition of reflexive says each and every member of X should be related to itself.
Right.
So this is not reflexive
Right.
for sure. And it's symmetric, it simply says if A is related to B, then B is related to A. So that if condition will tell you if anything is related to then the opposite. If there is nothing in the first place to start, then it is of course symmetric. And it is transitive as well. So this is one relation which is not reflexive but symmetric and transitive. Again, I'm sorry if I'm confusing you because these are examples normally which people don't think about often.
Okay, so if you go back to R being 1, 1, I thought we said that that was reflexive, symmetric, and transitive. But if it
No,
does
no,
not,
that is not reflexive.
okay. Because it doesn't have 2, 2 or 3, 3.
It doesn't have 2, 2 and 3, 3. Yes, it is symmetric though, right? And it is
Yes.
transitive.
Yeah.
So
Right.
if you think in terms of a graph, you should have a loop at each and every vertex, then that is reflexive.
Right.
If there is an arc from A to B, then there should be an arc from B to A to be symmetric. If there's an arc from A to B and an arc from B to C, then there should be an arc from A to C, that is transitive.
Transitive. Okay.
So those are the three things which are important. Non-transitive means it is not transitive. It is as simple as that. And you don't need to worry about strongly complete and complete. That's a comparatively very straightforward for you to see. The one thing which is not very easy or it is a little bit confusing is the one which is negatively transitive. Negatively transitive is a little bit, it's confusing. I don't know whether there is any problem in the exam which I asked. I tried to avoid negatively transitivity. Did I ask anywhere? I don't think so, but I'm just asking. But I will explain it. A new slide, blank. Negatively transitive means it is sort of a little bit confusing. The best way of the definition for negatively transitivity is this. The best way to understand. So for example, say X is a set of all real numbers. Now I'm defining something like this. A is related to B if and only if A is less than B. Now I ask, is this negatively transitive? The way at least you need to understand is this. You take all the pairs which are not related by this relation and those should be transitive. For example, 1 is related to 2, right? But 2 is not related to 1, right? So
Correct.
take the collection of all the things which are not related according to R, and that set should be transitive. That is the reason it is extremely painful for you to check whether something is negatively transitive or not, because you need to take all the ordered pairs which are not in R and prove that is transitive. So the best way to normally check whether something is negatively transitive or not is this. If A is related to C, then A should be related to B and B should be related to C for all A, B, C in X. That means if A is related to C, there should be a connection from A to B and B to C for all of them. So this is the best way to check. I'm going to give you an example. I think that is much better than all this nonsense I'm talking. Let's take an example.
Yeah.
Suppose I'll write this. This time I'll make hope I'm not putting any 4 there. Let me. Just somehow I'm fixated on this 4. Maybe let us stop here. Now if I ask, is this negatively transitive? the way you need to do that is, suppose in this case 1 is related to 1, right? Then you need to, then 1 should be related to, that is what it is saying. A is related to C means A should be related to B and B should be related to C for the rest of them. So if 1 is related to, maybe let us take this example. Say 1 is related to 2, that means 1 and 2 are covered. The only thing that is not covered is 3. So you should have 1 should related to 3 and 3 should related to 2. These two should be there as well. For example, if say 1 is related to 3, that means this is your A and this is your C. The B is the one which is missing. That means you should have 1 should related to 2 and 2 should related to 3. That means if there is an arc from 1 to 3, you should have an arc from 1 to 2 and also 2 to 3. That means there should be at least 2 different ways I can go from A to C. So for example, if 1 is related to 1, then the one things that are missing is 2 and 3. So I should have 1 to 2 and then 2 to 1. And also I should have 1 to 3 and then 3 to 1. All of them should be there. That means if I have 1 1, I need to have 1 2 and 2 1, 1 3 and 3 1. If I have 1 2, I need to have 1 3 and 3 2. If I have 1 3, I need to have 1 2 and 2 3. So the rest of them should be there, acted as connectors. Am I making any sense here, guys?
So this with this would not be negatively transitive.
This is
So there's no 2 to 3.
yes, this is not. Let me check before I conclude. 1 2 3 is there. That means you should have 1 2 and 2 3. Yeah, 1
You don't
2
have
is,
3.
but no 2 3. So this is not negatively transitive. It might be missing so many things, but this one is good enough for me to conclude this is not negatively transitive.
Okay, so I do have a question.
Mhm.
Because it says if A is related to C, like if 1 is related to 3, it
Mhm.
says A is related to B or B is related to C. Not and, but or. So does that mean one or the other as long as you have one? Makes it work?
Oh.
Or does it have to be both?
Yeah, it is one or the other. Man, I didn't see the definition. I'm so sorry. Let me check. Oh, it is or. If it is or,
Well, there just has to be a third item that connects 1 and 3, correct? Like in your example, there's only one option, which is 2. But if there was like 4, then it would work if there was a 1 4 and 4 3, correct?
oh yeah, but here for this example, you are right, but I'm talking about only this example.
Right. There's no other option, but just the only other item in that set is 2. So
Mhm.
that's the only other way to get
Yes.
from 1 to 3, right?
Yeah, one of them should be there. Yes, you are right. If I put 4, I can easily cook some. Yes, you were right. One of them. Oh, that is odd. Because even I haven't seen negatively transitive before. The rest of them are comparatively easy to think. Even graphically, I couldn't think of explaining it. I don't know how it looks like. So if there is a connection from A to C, then oh, this is OR. That is a nice point you brought it.
It makes sense. You just have another item to get you from A to C. Like the B is just arbitrary, correct?
But when you say OR, it might not be that true, right? You might go from A to C, but that means you need to have A to B or B to C.
Right.
So
Right. It makes
that
sense.
is not the other
Actually,
way.
it makes more sense. You need every way to get from C, a way to get to C. Correct?
I don't know, your
That
voice is cutting. Can you speak again if you don't mind? I think is your voice is not very clear. Maybe there is my side or your side. I don't know. Oh, this is OR, guys. This is OR. So if one is related to 2, then one is related to 3 or 3 to one of them should be there. 1 3 or 3 2. Okay, so 1 3 is there. So I am covered there. If 1 2 3, then 1 2 2 or 2 to 3. I think 1 2 is there. I am covered. If 1 to 1, I need to have either 1 to 2 or 2 to 1. That is there. 1 2 3 or 3 to 1. 1 2 3 is there. Oh yeah. Is there anything I am missing? Because once you put OR, that seems negatively 2 to 2. That means 2 to 1 or 1 to 2.
We got 1 to 2.
Mm-hmm.
Yeah.
Yeah. You have 1 2 here. If I have 3 3, that means and also I can have either 2 3 or 3 2. I think one of them is there. 3 2 is there.
Mhm.
If I have 3 3, that means I should have 3 1 or 1 3. 3 2
That's right.
or 2.
And you do.
Yeah, 3 1 3 is there. So one of them should be there. It is there. 3 2 or 2 3. 3 2 is there. Wow. This is the first negatively transitive thing I cooked up. Yep. Is that making sense, guys?
Yeah.
I think a little better.
Yeah,
Yeah.
I don't. Is there any example I can think of? In realistic example, I am seeing which I couldn't find, at least in my mind.
I don't know. Could you also, when you're thinking about some of this, could you clarify converse and uncle? Not necessarily to do the problem, but just to clarify.
Oh,
I'm
okay.
not-
The converse. Okay. A relation converse is if and only if. Okay, let me give an. Let's go to the insert. She's talking about converse. I will try to come up. Let us see. Let us think of an example.
I just kind of got lost in the uncle and aunt and father and son and. Oh my.
Oh, there's uncle and aunt.
I don't know.
Oh,
Uncle of.
Oh, in the converse thing you're talking about. Okay.
Yeah, there's several of the example, or like several of the problems had uncle of, or they had father of, or brother of, and I just could not understand what they were.
Right. I agree. The phrasing was kind of unusual. Yes.
Oh.
Through then. Oh, okay, whatever.
No, but you see, I saw only one thing with uncle of because I asked you to do one A and C. Both of them have no uncle.
Right. No, I was trying to
And-
figure out what the uncle was, so I saw it in several other examples, but I tried to figure those out and I couldn't figure those out. So I was like, oh.
Okay. Okay, if you are confused there, maybe let us do 1B. Let us do 1B, and I'll come back to this. 1B is not part of the assignment exam, right?
Right.
I'll come back to converse. X is the set of all people. And A is related to B if and only if A is an uncle of B. Do you think
Oh.
that means two people are related if the first one is the uncle of the second one?
So it's not symmetric unless you're a weird family.
There you go.
Yeah, none in my family
I
at
don't
least.
even want to think about that. No.
Do you think this is reflexive? Do you think this is reflexive?
That you're an uncle to yourself?
Mm-hmm.
No,
No.
that's not reflective. No.
Okay. And so, do you think this is non-reflexive?
Yes.
If it is not reflexive, no means non-reflexive should be yes. It is as simple as that.
Yeah.
Do you think that is irreflexive?
Yes.
Yes, because no person in the world is uncle of himself, right?
Correct.
Right.
Non-reflexive means it is true sometimes, not true sometimes. Irreflexive means yes, it cannot happen at any point of time. Okay. Now, do you think this is symmetric?
No.
No, right?
Yeah.
So,
No.
yeah, yeah, because yes, you guys mentioned the same reason. Do you think that is non-symmetric?
Yes.
Yes. Right? If it is symmetric,
Yes.
no means
Yes.
non-symmetric. Yes.
It is non-symmetric.
And let's put a new slide. And do you think what is symmetric?
I think it's asymmetric.
I think,
Mhm.
yeah, I was going to say, I think it's asymmetric.
Yes, because if A is the uncle of B, then certainly B is not the uncle of A, right? So this is
Okay.
asymmetric.
Correct.
What about anti-symmetric?
No.
Yeah.
Because if
If
it
you
were,
know-
that means you would have to be yourself.
And it would be,
Well,
yeah.
I don't know.
Man,
thought-
yeah.
If you could-
Anti-symmetric meant if it was true, then they were the same person.
If
Correct.
A is the uncle of B and then B is an uncle of A,
If that was true, then they would be the same person, correct? Is that anti-symmetric?
that is what anti-symmetric.
That's not true because you aren't the uncle of yourself.
Exactly, because this is not even reflexive to begin with, right? So you are not uncle of yourself, right?
Right.
So this is not an anti-symmetric. Am I making any sense? That's the same mentioned, the reason he mentioned.
So to be anti-symmetric, it has to be reflexive.
Let me say, because I don't want to draw any conclusion like that. I don't want to draw any conclusion like that. No, that's not true. For example, if I say 1, 2, and 3,
Oh, when we did the one where it was greater than,
no, but why? Why just take 1, 1? Yeah, this is, I think, anti-symmetric but not reflexive. So I cannot conclude anti-symmetric. Don't jump to those conclusions.
oh, because anti-symmetric has just one value, but to be reflexive means all pieces.
All of them
plus-
should be there. All of them should be there.
Okay, got it.
What
That's
about?
ex-
Do you think this is transitive?
Oh, I can't think that hard. Hold on.
So if A is the uncle of B and B is the uncle of C, then A would be the
Yeah,
uncle
great
of C. Like great uncle?
Yes.
Yeah.
Yes.
Yes.
Really?
Well, if you want to call it an uncle, but it's a great uncle.
True.
Oh boy, okay.
Well,
This is
exactly.
your mother.
Yeah, if like you're the mother of so and so, and that person is the mother of some other person, and you're the mother of the third person. But that's not true. You're the grandmother.
Right.
Yeah. So great uncle and uncle are same. I thought that is different.
I
I
think
mean, they're not an uncle, it's a great uncle. I
Yeah.
don't think that relationship works.
At least I see great uncle and uncle are two different people and two different relations. I mean, of course, they're different people.
Well, if you make it a different context, like mother or father, then it doesn't work.
Okay, man, English is such a weird language, isn't it? Okay, so I'll take this as transitive no. That's what I see. I'm sort of distinguishing between uncle and a great uncle here. So it is non-transitive. Yes, because if you say transitive no, then non-transitive should be yes. Now negatively transitive.
Oh, wow.
It could
Negatively,
be.
negatively transitive simply tells you this. If A is related to C, that means there should be another person. A is related to B or B is related to C. That means if A is an uncle of C, there should be someone in the world such that A is an uncle of B or that B should be an uncle of C.
Not necessarily.
No,
Yeah,
I don't think that has to be. No.
no, certainly not, right? It is saying it has to be. If A is an uncle of C, there should be at least one person in the world such that A should be an uncle of B or that B should be an uncle of the C. No, not need not. No, so this is not negatively transitive.
No, it could be true, but it doesn't have to be true.
But it doesn't
Yeah,
have to
it
be.
could be, it could be. But when you say this one, it has to be. That's what it is saying.
Okay.
And not only that, it is saying for all B belongs to X. That means take any other person in the world. That person either is uncle to you or the other guy. That is what negatively transitive tells you. For all A comma B comma C belongs to X. So that means if A is an uncle of C, each and every person in the world is related to either A or C by that relation.
Mm.
So certainly not.
Mm.
That is certainly not.
That one makes my head hurt. Yes.
Mhm.
Yes. So now I am going to go. Is that making sense, guys? So that's what I think you need to do for 1A and 1C. They both are comparatively much easier than 1B.
Yeah.
Okay.
I think I have a better idea at least.
Yeah,
Okay.
it makes more sense now. Yes.
So can you hit
Actually,
converse?
Yes, I'm going to hit converts now.
Either
Yes, sir.
Real world examples actually makes more sense to me for some reason.
Sure. Thank you. So let us talk about the converse. Again, I'm trying to explain with the help of an example. I'm putting an R here. Say this is say R. Now I am going to define R inverse like this. This is another relation. According to this relation, I need to figure out who are all the members in R inverse. Two people are related according to the inverse if and only if B is related to A by R. That means you want to figure out, do you think 1, 1 will be there in R inverse? That means, yes, 1, 1 other direction is there. Now, if you want to figure out is 1, 2 is there in R inverse or not, then you have to go back into R and check is 2, 1 belongs to R. Do you see 2, 1 anywhere in R, guys?
No.
No, so 1, 2 will not be there in R. But if I ask is 2, 1 is in R inverse, I'm sorry. Then you will go back to R and check is 1, 2 is in R.
Ah, okay.
Am I making any sense?
I missed something on that. Could you just go through that again?
I will go through that again slowly, okay? Now you want to figure out, suppose, give me any two members in X. Give me any two numbers in X.
2, 3.
2, 3. Now, if you want to see is 2, 3 is belongs to R inverse, is in R inverse, then you need to check 3, 2 is in R or not. If 3, 2 is in R, then 2, 3 is in R inverse. Do you see 3, 2 there anywhere in R?
Yeah.
Yes.
So I'm seeing 3, 2 in R, so 2, 3 should be in R inverse.
So 1, 1 should be in R inverse, 2, 1 should be in R inverse, 2, 2 should be in R inverse, 3, 3 should be in R inverse, 3, 1 should be in R inverse. Is that right?
Exactly. So
2, 3.
simply, yeah. So all you are doing is just flip each and every damn ordered pair. That's all you're doing.
Just like in
Okay.
functional inverse.
Yeah, exactly. So you pretty much know how the graph looks like now.
Gotcha.
Just flip it.
Oh, that makes the notation. So it's just like a functional inverse when you're switching the x's and the y's on the coordinates of the graph. It's the
Yeah,
same.
exactly. This is
Ah,
when you taught pre-calc or like college algebra, you talk about inverse functions, right?
Right.
This is an
right.
inverse. This is an inverse relation. A function might or might not have an inverse because if that doesn't follow like horizontal line test, it might not have an inverse. But every relation has an inverse. That is what they want to emphasize here. Take any relation, it has an inverse.
Can a relation be an inverse of itself?
Oh yeah. If I
Okay.
simply if I might take my R as 1, 1 and say 2, 2. That is my R. Then R inverse is itself.
Okay, gotcha.
Yeah, this is sort of, frankly, the entire notation is, I think, I personally feel it is sometimes confusing. But if you draw an example, it is just, you're just flipping it. That's all you're doing.
All right, good. Okay.
Yeah, the notation's starting to make more sense now.
Yeah.
Yeah.
I at least feel like I have a fighting chance.
No, not fighting chance. I'm pretty sure you all are going to do great. So you know pretty much. So if you want to figure out how the graph looks like, sketch the graph of R and sketch the graph of R inverse and see how it looks like. You know how to sketch the graph of R, right? 1 to 1 a loop and 1 to 2.
Yep. Yep.
And then 2 to 2 is a loop and then 1 to 3 is an edge. Then sketch the graph of R inverse and see how they're related.
And we can use examples as basic as this, right?
You can use examples, but in 7a, they were not asking examples. They want you to describe in words, just 1 or 2 sentences.
Right.
Okay, gotcha.
So example is for your benefit to understand, but when you're writing then the exam, don't give any examples because they haven't asked any example there. Describe, that's all they said.
Describe. Okay. Okay.
So just
put it in
describe. If
words.
you want to emphasize, you're right, just show me an example, but I am going to grade only your description, not the example.
Okay.
Mhm.
So we can draw the picture, an example, so that we can describe it in words to help ourselves.
Yep. Exactly.
Okay.
Yeah. Any more questions, guys?
No, I think my head's spinning enough right now. Yes.
Yeah, all right, I'm with you.
Okay, guys, take care. Then have fun if you can.
Oh, I will.
Thanks.
Thank
Thank
you very
you.
much.
Oh, anytime. That's my job. It's anytime. So I'm going to post one more assignment this week, and that should be your last one before the finals.
Okay.
All right.
At any point of time, if you want to meet on Sunday or anything, please email me. I'm more than happy to meet you guys.
Okay.
Okay.
Okay. Thank you.
Okay, sure, no problem.
Thanks a lot.
Oh, anytime.